Okay, welcome everyone. We're going to give everyone just another minute or two before we jump in and get started with today's expert session. All right, we'll go ahead and get started. Thank you everyone for joining us today. We're excited to bring another expert session to you today. My name is Andrea Kircher and I'm the Director of People and Strategy at Fortified Data. And I'm excited to introduce our expert today. He's someone we all know very well and has a wide breadth of knowledge. We're going to be talking about cloud cost optimization today. And we have senior consultant Frank Gill here with us. He's got over 22 years of IT experience, 14 specifically specializing in SQL Server. He's developed large-scale, highly available SQL Server environments for Fortune 100 companies. He has an expertise in performance tuning or performance troubleshooting and architecture design, and he's skilled at implementing new technology solutions for clients. And most recently, he's been spending a lot of time assisting clients making decisions around cloud cost and cloud spend. So we will let Frank jump in.
All right. And if anybody has questions as I'm going through, if you want to drop them in the chat, Andrea can get them to me as I'm going through. And then, Andrea, do you want to drop my email in the chat just in case there's a question that I don't have an answer to that I need to follow up on?
Absolutely.
All right. So as Andrea said, we're going to talk about cloud cost optimization. I am going to focus on Azure technologies because that is the world that I live in. If you have questions about AWS or Google, feel free to shoot me an email and I can see if I can get you the information that you are looking for. Um, so what I'm going to talk about at a high level is understanding your options, specifically for running SQL Server in Azure. Um, your options for migration, your options for new development, and then I'll talk about right-sizing resources because that is a big part of kind of the optimization is making sure that you have the horsepower that you need to run the workloads that you're running, and you're not, sitting with 80% idle CPU and potentially wasting money. Talk about workload management, some things that you can do to optimize your workloads within Azure, and then talk about monitoring for cost control. Basically, kind of looking at your systems, figuring out am I using the resources that I have? Can I scale things back? Do I need to increase resources to make my systems run more efficiently? Because that cost control, you want to reduce your costs, but if you have systems that are undersized, the systems may cost you less, but the amount of time that processes take and the headaches that you have around running on smaller hardware can actually increase kind of the cost of running the business. So with that, jump in. Um, so the first question that you should ask when you're moving to the cloud is why are you making the move? It's something that I've seen a lot of people miss. When it doesn't happen so much anymore, but when the cloud sort of became the new thing, I saw a lot of people who were looking to move to the cloud, just to move to the cloud because it was the new shiny thing. You want to make sure that you know why you are moving to the cloud. Um, from a migration standpoint, one of the big benefits to the cloud is actually kind of the two big benefits that I see in moving to the cloud are the ability to scale things quickly. So talking about having undersized systems that are not, serving your workload, it is easy to upscale your resources, to give them more processor, to give them more memory, to give them more storage than it would be if you were running in a physical data center. Um, the other thing is the ability to I've lost my train of thought here. Um, anyway, so that on the migration side, you've got the ability to scale. And then with if you're standing things up for new development, there are some options that may not be there, may not be right for you if you are running the migration. So making that decision of why you're moving, are you migrating existing systems? Are you looking to develop new database solutions in the cloud? Those are things that you want to figure out before you make the move and when you start planning that move into the cloud. So within the Azure world, there are basically two different offerings for running SQL Server. The first is platform as a service, and this is the benefit here. And I just remembered the second benefit to moving to the cloud, and that is that the resources that you are running in the cloud are managed by your cloud provider, in this case, Azure. So if you choose platform as a service, when you create an Azure SQL database or a SQL Server managed instance, and I'll describe those in more detail in a minute, the the underlying infrastructure of the database is fully managed by Azure. So in terms of just the resources that your databases are running on, you don't have to worry about things like Windows patching. Um, you don't have to worry about backups. You can automate your backups. So all of that stuff is managed. The other option is infrastructure as a service. And in the SQL Server world, this means running SQL Server on a VM in Azure. So you could sort of think of it as using Azure as your hosting provider. In that case, you are responsible for things like Windows patching. You are responsible for running your SQL Server backups. It's just the same as you running SQL Server on a virtual machine in a data center, in a hosting provider. So just kind of getting your head around those two options is important when you're looking to move to the cloud. Um, so talking about right sizing resources, your goal if you are migrating to Azure is to figure out what your workload looks like on-prem or wherever you're migrating from. You want to run a baseline on your existing systems, and you want a baseline for CPU, memory, and storage I/O. And based on that baseline, you can get an idea of how much hardware you need to allocate to the instances that you are migrating. Um, so there are some really good resources out there from Microsoft about what goes into a baseline. Um, the recommendation from Microsoft is to use a tool called Performance Monitor or perfmon, and perfmon allows you to capture this data on a rolling basis to see how your systems are running, how much CPU they're consuming, how much memory, how much I/O, and you can specify counters for these. Uh, Additionally, there are third-party tools out there. So if you have a third-party monitoring solution for your SQL Server environment, you can use those tools to generate these baselines, and those tend to be kind of more user-friendly. They give you the ability to generate kind of fancier reports and stuff, but perfmon will give you the data that you need. And as I said, there are some resources, good resources out there. If you have questions about those, shoot me an email and I can get you specific information about running a baseline. And then, as I said, you want to take that information and use that to size your servers, because that will give you a fairly good handle on how big those servers should be out of the gate. It's not to say that you might not need to tweak things down the line, but it just gives you kind of a good landing place for your stuff, your databases in the cloud. Something else to think about in terms of reducing cost specifically for SQL Server on Azure VMs is to make sure that you're using the right edition of SQL Server. So the three I've got flagged here are Enterprise, Standard, and Development. If you aren't familiar, Enterprise is sort of the full suite of SQL Server features. Standard has there are some restrictions on the things that you can do with Standard Edition. There, as new versions of SQL Server have released, the number of features that are not available in Standard has dropped. But from my perspective, a lot of what I do is high availability and disaster recovery. And one of the biggest differences between Enterprise and Standard is just the features that you have around HADR, um, specifically availability groups, and then clustering, the things that you can do with failover cluster instances and availability groups. There's still a pretty wide divide there. So figuring out if you can run on standard, if you can, it is much cheaper from a SQL Server licensing perspective, but that is something that you want to figure out before you make the move to the cloud. Um, and then actually it's developer edition. I've got a typo there. Developer edition is what it says. It's an edition specifically for SQL Server development, and it has the same feature set as Enterprise. And as long as you are not running a production workload against that development instance or developer instance, you do not have to pay licensing costs. So these are things to keep in mind. You know, if you are going to be standing up environments for test and prod or test QA prod, you want to look at potentially using developer licenses and saving yourself money that way. Um,
We do have a question, Frank, when
sure.
you can. So it says this is from Patrick. We've been fully in the Azure cloud since 2017. Is there a utility to evaluate if our resources are right-sized and consistently using the correct cloud resources? So that's part one.
Okay.
Do you want me to read the rest of it, or you want me to start with
I
that?
was just going to say that kind of the last thing I'm going to talk about is monitoring. So there are tools, and I'll talk about those in detail. And then if you have further questions after that, let me know.
Okay. I think the second part will probably fall into that then. So
Okay. Okay. Yeah. So as I said, let me get there. And if I answer your questions, cool. And if not, come back and I will do what I can to answer them.
okay, and
Um,
there's one more too before you
sure.
continue on. All right, it says we are AWS and AWS doesn't have fully managed RDS for SQL Server Developer Edition. Any suggestions on that?
I don't off the top of my head, but Andrew, can you make a note? And if you want to shoot me an email, I can get you a better answer.
Yes, I'll make a note and I'll also share your email.
All right, cool. So, speaking about migration, so basically, when I'm talking about migration, I'm talking about taking an existing SQL Server environment. So you are running instances of SQL Server on VMs and you want to move them into the cloud. So I talked about infrastructure as a service, the idea of moving that workload from a VM where you're running it or from a server where you're running it and moving it to the cloud and running on VMs in Azure. So that is an option, but you do not get the managed kind of service part of the cloud by running on VMs. With the platform as a service option, Azure provides something called SQL Server Managed Instance. And what this is it looks and feels like an instance of SQL Server. If you open up the Instance and Management Studio, you will see everything that you expect to see if you were running that, on-prem. You have access to the SQL Server agent. You have the ability to run cross table and cross database queries. Um, and once again, you want to baseline your existing systems using the same methods that I talked about with the infrastructure as a service, and then use those numbers to size your managed instances appropriately. Um, it is a little different in terms of what you are going to look at in terms of allocation, because with the infrastructure as a service, You can kind of think of it as a one-to-one. You have a number of cores, you have the number of memory or an amount of memory that's running on-prem, and you want to kind of mirror that when you move to virtual machines in the cloud. With managed instance, there are different uh, kind of different offerings that there is somewhat of a map between the number of CPUs, the amount of memory, and the storage, but it's just a little different. So you want to make sure that you understand how to do that mapping, and there are tools within Azure to kind of get you that in terms of both cost estimation and the amount of resources that you need to allocate to a managed instance. So and then within the managed instance world, there are what are called service tiers, and there are two of them. There's general purpose and business critical. And this goes to what you need in terms of things like RTO and RPO, recovery time objective and recovery point objective within your applications. Um, so there is one of the nice things about managed instance is high availability and disaster recovery is built in. And with general purpose, that high availability disaster recovery technology basically runs via storage redundancy. So your database has a data file or data files and a log file. Um, Azure replicates those files to multiple sites. And if there is an issue with the compute node that is running your managed instance, what it will do is it will spin up a new compute node and then point that new compute node at one of those storage, redundant set of files. So the failover time can be in the seconds. It is pretty quick, but it can be in the seconds. When you provision business critical, you're effectively provisioning an availability group architecture. So you have log records that are being pushed from a primary replica to secondary replicas. And in the event of a failure, you're effectively just getting an AG failover. And that runs generally in the milliseconds. So you have um, much faster failover, and you also have the ability to designate a replica within business critical as a readable. So you can run reporting or backups or other workloads that might interfere with a transactional workload. You can run those off of a replica with business critical. And then another thing to think about in terms of optimizing costs is the licensing model. And there are sort of 2 points to this. One of them is there's what's called the Azure hybrid model. So if you have an enterprise agreement with Microsoft with software assurance, you can use existing SQL Server licenses to apply to your managed instance. And with general purpose, I believe I'm not a licensing expert and I don't play one on TV, but I believe it's for one license on-prem, you get one core license on-prem, you get 4 core licenses for the general purpose offering. And if you're moving to business critical, that is a 1-to-1. So 1 core on-prem, you get 1 core in business critical. And then on top of that, you also have the ability to provision these resources as pay as you go. So it will charge you an hourly rate, and you can look at that from an hourly perspective or a monthly perspective when you're estimating these costs. But you also have the ability to pre-purchase the resources, and this can drop your cost by, I think, for managed instance, it can drop your costs as much as 55%, depending on how much capacity or how much capacity you reserve. And then when we start talking about Azure SQL Database, which I'll get to in a second, that number can get even higher in terms of the savings that you get. Uh, so that is licensing. So that was all talking about migration, this idea of taking what you have on-prem and moving it into Azure. Um, in terms of new development, if you are looking to stand up new resources, you are building new applications, and you want to do this in the cloud, something you might want to look at is using Azure SQL Database, which is part of the platform as a service offering. The biggest differences between Azure SQL Database and managed instance on the platform as a service side is you do not have the SQL Server agent. So if you currently have processes that are running via SQL Server agent jobs, you can't stand those up in Azure SQL Database. There are other mechanisms within Azure that will allow you to schedule workloads, but you can't, move agent jobs up in Azure SQL. Um, the other big difference is uh, you do not have cross database, I should say, you do not easily have cross database communication. So in a standard instance of SQL Server, I can write a join with a four-part name where it's database, or sorry, server name, instance name, database name, schema name, table name, and I can join between databases. You can't do that with Azure SQL Database. With that same functionality or that same kind of code, what you can do is create what's called an external table, and you can link to other Azure SQL databases that way. There is a lot of work that goes into that. So that's something to consider. If you have that need, you may want to look at managed instance rather than Azure SQL Database. But one of the use cases that Microsoft kind of puts forward for this is if you have a multi-tenant system. So if you have multiple customers and they all need the same database schema, you can create multiple Azure SQL databases and point each client at their own version. In terms of right sizing this, testing is really important here. You want to look at, allocating resources and starting small, and then running test workloads against them, monitoring and looking at how that workload is running, and potentially growing those out to meet your workload. So that is kind of my advice around standing these up for new development. Um, Under Azure SQL Database, you've got two different service tiers. Or there's several service tiers. There are two different purchasing models. One is vCore, and this you're actually buying when you go to buy or go to provision your resources, you are provisioning CPU and memory. And under the vCore purchasing model, you have general purpose and business critical, and those map to what I talked about with managed instance in terms of the high availability infrastructure that sits underneath them. And then there's a third offering called hyperscale, and this it's really performant because of the way that it manages your data and log files. Um, just not, I don't want to get too deep into the weeds, but if you think about a transaction log file, so you are running a workload against SQL Server, you are writing to the transaction log file, and the speed at which you can write to the log file can impact the performance of your system. With hyperscale, effectively, the transaction log file you can kind of think of it as being tiered in terms of storage. You still have your transaction log file that is being stored on disk, but as changes are being made to your database, they are all being made in local SSD. So it speeds up the process of processing transactions. So it's something to look at if you have a very, resource hungry OLTP system. Hyperscale may be something you want to look at. Um, there's a second purchasing model called DPU, which is a database transaction unit, I believe. And basically you're purchasing a certain number of DTUs and you're consuming those DTUs. And the DTU is a roll up of CPU memory and storage IO. And there are some formulas out there to kind of calculate what the DTU maps to in terms of resource processor consumption, memory consumption, that kind of thing. And then under that model, you have standard and premium. And there are restrictions on standard, specifically around kind of the architecture that sits underneath it and what you can expect from that kind of high availability disaster recovery perspective. Any questions?
Nope, I don't see any right now.
All right. Then just one other point to make in terms of potentially reducing cost with Azure SQL Database. There are two different compute tiers. The first one is provision compute, and this is where you are saying, and these only apply to the vCore model that I talked about on the previous slide. But provision compute says, I am looking for 4 cores and a certain amount of memory, and that is what I will be provisioned, and that will be there regardless of how much workload is running on it. And in this tier, you are billed per hour. There is a second tier called serverless compute. And with serverless compute, your Azure SQL Database environment automatically scales. So you set a baseline, you set the amount that you need, and as the workload increases, it will automatically scale out. And that is billed per second. So if you have a system that is idle for a lot of the time, but then you have bursts of activity, you can stand up a serverless compute node and it will handle those bursts of activity. And once that activity stops, it will drop back down and you will be billed per second based on the resources that you are actually using. This is generally available in both general purpose and hyperscale currently. So it's not available in the business critical offering for the vCore model in Azure SQL Database. And then one other thing to talk about. Oh,
sorry, we have
question?
had a question pop in. What are your thoughts on serverless databases, performance and cost versus performance trade-off?
It it depends. Like everything else in SQL Server, it depends. I think that there are definitely use cases for it, especially kind of in that scenario where you have that sort of burstable activity. Um, from a performance standpoint, there once once you get up to speed, once it gets to the point it needs to be at, it's going to perform just like the provision compute would. There is some overhead in spinning those resources up, but from what I've seen, you know, if it makes sense for you, you can sort of handle that. It's one of those trade-offs where you're spending less money when your system is idle. There is a little bit of ramp up time to get the resources where you need to be, but you're effectively just paying for what you're using. And it does depend. It depends on your workload. It depends on your ability to kind of weather that roll up. If you need to make sure that you have the resources that you need all the time, provision compute's the way to go. So it's something that I would suggest doing extensive testing to make sure that your workload can handle kind of that overhead of serverless compute. But in the right use case, I think it's a really good idea and it can really save you money.
Great, thank you.
All right. So I think this is the last thing I'm going to talk about on the platform as a service side, and it is resource pooling. And resource pooling is available for both Azure SQL Database and SQL Managed Instance. And effectively what this is in the for Azure SQL Database, you are buying an elastic, they call it an elastic pool. So you can kind of think of it as a pool of resources, and then you can point multiple Azure SQL databases at this pool, and they will share the resources that are provisioned to that elastic pool. And a use case for this, I talked about Azure SQL Database. One of the use cases being a multi-tenant system where you have a database a schema per client or customer. You can use elastic pooling to give those databases the resources that need. And if you're looking at running a business that is global, so you have different clients that are active during different times of the day, an elastic pool can potentially give you the resources that you need and allow those workloads to kind of shift through time. So you have clients in the United States, they're running, from 8 to 4 local time, and then you have clients in Europe that are coming online and running sort of a different part of that 24-hour cycle. And then once again, moving to Asia, you can kind of provision the resources and allow those different clients to share them and effectively potentially reduce the number of resources that you need to allocate. With managed instance, you have what's called instance pooling, and it's the same idea. You can allocate a pool, an instance pool, and then point multiple SQL managed instances at it. Two other kind of benefits of instance pooling for managed instance is a single managed instance, the smallest, the the least number of processors you can allocate is 4. With instance pooling, you can allocate a 2-core managed instance. So it gives you the ability to use those resources more granularly. And then the second advantage is managed instance has gotten a lot better in terms of the actual spin up time. When managed instance was released, it averaged about 6 hours to build out the managed instance from that first, when you clicked create, it would take about 6 hours. It's now dropped anywhere between 30 minutes to 2 hours. But if you're using instance pooling, you're basically building out the infrastructure you need for managed instance with that initial build. And then as you create new managed instances within that instance pool, it can use that same infrastructure to stand these things up, and it will run much more quickly. So that is resource pooling. Any other questions?
None at the moment.
I will move on to workload management. And this is not going to be cloud specific necessarily, but these are things that you want to take into consideration with any workload, but specifically cloud workloads, because you are trying to reduce the resources that you need. You are trying to reduce the size of the workload you're running. And by doing that, roll back the number of resources you need. And the 3 things I'll talk about are data compression, partitioning and archiving, and index optimization. Data compression is available for all of the Azure SQL offerings I've talked about, and that is, Azure or SQL on an Azure VM, managed instance, and Azure SQL database. And what data compression does is it reduces the amount of storage that you need. And it also reduces the amount of I/O that you need to get your data from disk into memory, because the data is only decompressed when it gets to memory. There are 2 different compression algorithms. The first is row compression. And at a high level, this is effectively taking the data that you are storing and it's doing things like taking variable character fields. Character fields. So if I have a character 500 field and I'm only storing 10 bytes in it, 10 characters in it, row compression will treat that as a 10 byte field. It will remove the extraneous information and it keeps track of how big the field should be. So when it decompresses it, you will get the full 500 bytes. And then on top of that, you have page compression. And with page compression, SQL Server is effectively building a data dictionary or deduping the data. So if I have, um, something like a state code or a state name, um, it will store. I'm in Illinois, so it will store Illinois in the data dictionary, and then it will have a pointer to all the examples of Illinois that are actually stored in the data. And so there's a process of, kind of putting that data back together when it decompresses it, but you get more bang for your buck in terms of compression. It will compress more tightly. So those are things that you want to look at potentially using in SQL Server to reduce both your storage footprint and also reduce the amount of I/O that's required moving from disk into memory. Partitioning and archiving, this is something that's available for all the SQL offerings. Partitioning divides your tables and or indexes into smaller chunks. And two of the things that you can do here is you can run partition level maintenance. So things like backups or statistics updates, index updates can all be run at the partition level. So if you have, say, a table that's got 10 years of historical data and you're only writing to kind of the first partition, the year zero partition, you can run all of your maintenance on that year zero partition because